Welcome to another episode of Lunch and Learn with Vince. I'm your guest, Vince Marino, and I've got a great guest today, Dean Sarandria with TECO-Westinghouse. Dean, welcome. Welcome.
Hello, glad to be here.
Good deal. Well, we're going to talk about something interesting. It has to do with becoming green, right? And I wanted to find out a little bit more about what TECO-Westinghouse is doing. And let's just start there. I mean, tell us what's going on as far as TECO-Westinghouse becoming more green.
Right. We really started with Department of Energy working on some programs that started with medium voltage drives. And then we, of course, build motors here in our facility. But we also started a high-speed motor that was done with a DOE grant through Clemson University. The purpose of this was to design a very highly efficient motor that could be used to push CO2 down into salt caverns and then bleed it back out at when the power was actually needed, because most of the wind business in the central part of the U.S. can't get to the city or is not available. So when it's needed, so they were going to look for a storage facility, and this was what they thought about. So we won the DIA program, and we built a motor, and we used a specialty motor with running at 400 to 500 hertz, and then we developed a new, what they call SiC MOSFET drive, so we can take the power and either do it in a very small footprint, and it's a very cost-efficient process. And then we can tie that to a compressor and use that to push the CO2 up and down. But the problem was, in the process of that business, I guess the DOE found out that whole system doesn't really work. But part of this was the commercialization part of any DOE contract. So we took the commercialization piece and started looking out there, because we could now run at 15,000 RPM using standard ball bearing motors. And then run it with the drive, and we could tie that to a compressor and get rid of the gearbox. So that's where we started on that path. And then in the process of doing that, I met with a compression company and AG Equipment out of Tulsa, Oklahoma. And we were talking, the engineer and I were talking about this particular process, and he said, well, you know, I've always had this idea of we take the heat of compression when we smash our atoms, we end up with this heat we have to get rid of, and we put it into a motor, call it a fin fan type operation. So we have to take that heat out of the gas stream, and then we have to pay for the motor, we have to pay for the energy for the motor, and I've always wanted to take that heat and use it. So we sat there and talked about it, and we thought about this green energy system and how we could make this work, because there's thousands of these types of applications and compressors for the shale gas business. And we came up with using the Rankine cycle with a turbo expander connected to the high-speed generator, and then into a regen SiC drive, which makes it very efficient. And now we could take this heat that is normally thrown into the air, and we can capture it and put a megawatt of power back into our grid. And that grid can be either 460, 4160, or 13.2. The drive was as part of the package with the DOE and Clemson University, was to be able to handle any voltage output. So we'd actually built a prototype of one of these for the DOE, and it was being tested. And we decided to build a second one. And in the process, when we put it all together, it looked like it was a very efficient system as far as a 1 megawatt compared to if you put in a wind turbine or solar field. And if you package all this together, it was a very efficient operation, and we applied for a patent, and we got it. So now we built a prototype. We're building a second one now, and we're actually looking for a pilot program. And the Department of Energy, we won another project to actually install it as a pilot project. So we're in the process of looking for that right now.
Wow, that's amazing. Now, can you take me through, I mean, how long ago was the birth of this project? How long did it take to get to where we are today?
This project started about 8 years ago, and it was, of course, when you deal with the Department of Energy, there's always lots of gates, go, no-go decisions. And as we're going along, there were a lot of things that they wanted and didn't want. There were actually 4 or 5 other motor manufacturers or people that were participating in this. But as far as I know, we were the only ones that managed to go through with the motor at the 15,000 RPM using standard bearings, because everyone else, I believe, uses mag bearings, which is a whole another issue. And we use like it's called a squeeze damper film ball bearing, which is typically off the shelf. And it took time to actually manufacture that. And then we also had the SiC at the time, although SiC was a silicon carbide, is the new technology for drives, which is highly efficient. They're using them in a lot of electric drive operations for cars, but it's at a very low voltage. So this was the first time it had ever been done at a 4160 volt operation at 500 hertz. And the reason you use the SiC is because it allows you to handle the switching frequencies, just a lot of heat and a lot of time. So we had to, take we call it a MOSFET, and we had to get, we call it gate driver, and we had to do a lot of testing and a lot of samples and a lot of programming. And after about 1.5 years, we developed a fully functional SiC drive.
It's amazing. So how is this going to help us in the future? How is it going to help the world? Clearly, there's all kinds of initiatives now in infrastructure and so forth to become more green. Maybe you can tell me a little about the carbon footprint and things like that. I mean, tell me, how is this going to benefit us, the world?
That's a great question, Ben. And let me tell you, the thing that really excites me about this is from a green perspective, and this is through the Department of Energy type of numbers, that this process will save about 8 million pounds of CO2. And from a green perspective, that's a lot. And this, you got to remember, this heat was being blown into the air. So you're taking, in order to make that heat go into the air, you're burning electricity on top of that. So this process allows you to capture all that and reuse it as a megawatt. And in the process of using the 500 megahertz unit, we're able to do this at a high efficiency and a low cost that is lower than the installed cost of a wind turbine or a solar field.
Unbelievable. I would imagine that there's an incredible amount of excitement associated with this. This is the first I'm hearing about it now, but I got a little taste of it at the ESA show. We talked a little bit there. I met with Lana and Jessica and so forth, and I was pretty excited to hear about all this. I mean, it looks like you guys really do have a great vision, and it looks like it's coming to fruition. So congratulations on that. I'm wondering if there's anything else you want to add to that as far as, I've got a few questions, but if you have anything else that you might want to, expand upon there while I look for my questions.
Yeah. Well, there is one I would like to. The
Yes.
omnibus packages that were passed in December, there was actually a section in for this product to get 28% ITC. And so if anybody that uses this product, not only are they going to be green and save carbon, if they do it in the next 3 years, they will receive an investment tax credit that they can apply. And the investment tax credit doesn't just involve the Rankine system and this high-speed motor and drive, but it also involves all the information and activities you have to do to install it on your site. So it's a fairly large ITC. It's very similar structure to a wind or solar farm. I had a price Cooper House do a white paper on how to apply it, and we're happy to send that to people that have interest in doing the pilot or purchasing a system for their use.
So somebody that's watching this video right now, how would they get in touch with you to learn more? Do you have a particular email address or website, or do you have a document that you want to share on the screen? Or we certainly will put that in the comments section below the actual video when it appears on YouTube, some links and so forth. But can you tell us a little bit about how somebody, that's dealing with these issues right now that goes, hey, you know what, I want to get in, I need to utilize what they're doing. How would they get in touch with you?
They can contact us at 512-939-0957 or email us at www.TECOWestinghouse.com.
Perfect. And so some of the other items that you guys are working on, are you able to share? So it sounds like you've got a lot going on. Are you able to share any of the other items or anything else, that
Yeah. We're also looking at a lot of applications for electrification of the oil fields. And we are building, we call power sleds here in our factory that replace the engine with an electric motor. And we build it all on a portable sled that can be used to replace an engine-driven compressing unit out in the field.
So you said
we can do the entire systems engineering concept, and we can build the product. Of course, we build motors and drives a lot, and we have relationships with compression manufacturers that can put that together as well.
Incredible. So I want to hear a little bit about your background. Where do you come from, Dean? Where did you start all this?
I was born in Pittsburgh, and I got a chemical engineering BS degree. And I started with Westinghouse, and I was going to originally be involved in the LERG process because when I graduated, there was only like 5 to 10 years of gas reserve, oil and gas reserve left. And so the Germans in World War II had developed they call it the LERG process to extract oil from coal. And Westinghouse had actually built a pilot unit, and we were going to go out and sell that system because, of course, we have a lot of coal. There wasn't a lot of green energy regarding at the time. So it was a matter of coming up with this process. As soon as I got in there, though, I guess they found out that there was oil and gas when I joined Westinghouse, and I've been there ever since. So I've been involved in a lot of different applications, a lot of different groups within Westinghouse. Westinghouse is not quite there anymore other than where I am today, where we build large motors and custom products.
So let me just add, I mean, just you and me talking here, but was there any resistance or hesitation when, this is a whole new way of doing things, right? I mean, we've been blowing wasting hot heat up and, for as far as I can remember. I mean, if you said Pittsburgh, right?
Yeah.
I'm an East Coast guy. I remember driving by refineries and seeing the flames going up. I mean, to go, wait a minute, guys, we're doing this all wrong. Let's harness this, right? Were you all met with resistance, or did you think, well, I don't know, or was there some skepticism, or you just went ahead and no, this is the way it's got to be? Or tell me.
Well, for this particular product, it's always been interesting to work with the Department of Energy and our government. And we actually worked with the Department of Defense on superconducting motors and magnets.
Right.
We since abandoned that because it just wasn't a feasible option for a commercialization program. I think the government's using it for some destroyers and things, but actually a couple items. But this particular item with the heat recovery system, it doesn't have to be with the compression side of business. It can use anything that has heat that we can run through a turbo expander or something that turns the generator. So it can be used in utilities, biomass, geothermal, metal manufacturing. There's a lot of different applications. I only started with the oil and gas only because our company is very heavily involved in oil and gas. from the motor and the drives and systems and servicing of all this equipment. And so having this particular product to apply into that industry, it was very exciting. That's my chemical engineering background and relationships and things with AG equipment. It was a perfect fit, and we jointly went after this patent, and we were awarded it, and we have successfully commercialized an R&D program that was started in the Department of Energy. So part of your tax dollars is involved in this.
Well, I think it's wonderful. Do you think, I have a couple of questions. Some of these are, pretty basic because I am not a chemical engineer. I was fortunate enough to have a dad that was, and I do admire that career path. So do you think that the transition to 100% renewable energy will be feasible, and or will it be expensive, or how do you feel that's going to happen over the years?
Well, I think about when I started 40 plus years ago, there wasn't much of electric vehicles. There wasn't wind turbines back then were maybe 100 to 200 kilowatt. I mean, they were very small. It was basically coal-fired all the way. There was hardly any gas. It was sort of like you talked about seeing burning things, like they call it a flare, right? They just burned it off as excess. They didn't want that gas. Right? And so you go over the years, and we built a lot of coal-fired plants. I just traveled the world, and we put coal-fired plants everywhere within Westinghouse. We did nuclear plants. Right? That was a rage for them until 3 Mile Island happened. And now, coal is sort of, even though they cleaned up all the coal, and when you look at a coal, that smoke coming out, that white smoke is typically water vapor. They've made them put so many cleanup activities that it just doesn't, it's not throwing out the pollutants like they did the NOx and the SOx and the mercury, as I understand it. So, but if you look at that business is basically gone now. They're closing them down all the time. Wind is growing. It's very strong. And I think we actually built wind here in our facility. We built, at the time, was a fairly large one, was about 2 to 2.2 megawatts. The ones that we're talking about building in our facility now are upwards of 5.5 megawatts and almost the same footprint. So if you look at the technology changes that are occurring, this is a great thing. It's kind of fun to watch. I think looking at the solar side of the business, we're involved in solar with our company, but mainly in our parent company, which is called TECO out of Taiwan. But if you look at the cost of a solar plant, they used to lose money, and today they make money. So you can look everywhere. Solar for signs, solar on a computer, solar in a home, solar on a utility scale. So and you look at the batteries that go along with that. We also make BESS systems, which is a battery electric supply system that goes inside of a container. And we've done a couple of those. We actually did one with an oil and gas company where we used the solar field to feed 2 megawatt BESSes that fed the electric generation for the compressors. So, I mean, there's a lot of ways you can mix this together, and you develop what we call a microgrid to pull all that together. So from the BESS situation, that's looking at the batteries, and batteries have changed drastically.
Yeah.
We're involved in car chargers today. So if you look at the type 1 charger, which is probably in your house, takes you 24 hours to charge your car, all right? Or you have a type 2 that may take you a couple hours to charge your car. And now the level 3s, or the DC fast chargers, you'll be able to charge your car in about 15 minutes. So you look at all the major car manufacturers, like Ford, the F-150 that's going to come out, will be able to use some of these fast chargers. So if you look at the typical system is called on the go. People, when you're traveling, if you buy an electric car, which 35% of the cars on the market by 2030 are supposed to be electric. If you look at that, it's going to be, you get in your car, you go out now with a gas car, you just find a gas station, you go in and fill up your gas. It's going to be that same way with electric vehicles. You're going to go on the go. You're not going to charge at home because you're not going to have that much time, right? So you're going to go on the go, and you're going to find a fast charger, and you're going to hook up.
Right. The time it takes to have a quick lunch or a cup of coffee, and you're your car's charged. So
There you go. Yep.
did you say 35%? Was it 30 or 35% cars?
It depends on which site you go to, but I believe some of the DOE sites are talking between 30 and 35% of cars on that. Of course, it depends. Like if you look at California, I think they're going to be there faster than the rest of the country.
Yeah.
But you look at Ford, the Tesla mega plant that's being built here in Austin, Texas. There's a lot of activity going on. And we will actually build car chargers here in the U.S. and have a U.S. manufactured.
That's exciting stuff.
So, yeah. So we can tie a BESS system. So you asked me, will the grid? I think the biggest problem is will the grid support all this electricity? And of course, solar only works at a certain time of the day, and wind only works when the wind blows. So you have to find alternative sources, and a lot of people are going to batteries. And we do these BESS systems, 1 or 2 megawatt units, and we're looking at coupling the BESS system with the electric charger. So that helps stabilize the grid. And it's also a two-way communication. So if it's not charging the vehicle, the battery power can be put back onto the grid.
Awesome. Let me ask you this. Yeah. Aside from my Lunch and Learn show that we're doing right now, what are some of the other tools that you guys are using at TECO to share your vision of this, of a green new TECO? What other resources are you going to different trade shows? Are you on the local news? I mean, you mentioned Houston or Austin. You're just a few miles away from Austin, right? You're
Yes. Yeah.
So
a little north of Austin in Round Rock, Texas.
So I'm sure there's some, I would imagine some articles in the papers and so forth.
There will be.
Will be.
Yeah, can't quite get involved in that right now, but yeah,
Yeah.
There's a whole marketing plan to go forward.
I'm glad to be at what I consider the tip of the spear in a way. I mean, I feel grateful. I do find it interesting that it took 8 years to get here, Dean. That's amazing. Yeah. But you got here. I mean, there's probably a lot of, like you mentioned, I would imagine a lot of other people certainly took a look at it and, you know, in year 3 gave up maybe, you know, so it took tenacity and staying power. And I got to tip my hat to you on that. That's outstanding and quite exciting. Let me ask you this. Looking at the other side, are there any negatives or pitfalls to going green, green products? I mean, I can't think of any, but I mean, I'm just trying to, I mean, what's the harm?
I think it's all in the imagination. It's whatever you can come up with. I mean, there's going to be a lot of different innovations. I think the battery systems are what's going to really change.
Yeah, I mean, certainly, there's no doubt. The technology, I think that we're at a juncture where our aspirations and desires are now coinciding with the technology that has caught up with our interests. So technology and the need kind of have met at a crossroads, and now we're at a point where we can use the technology that we've evolved to do these applications. I mean, you could 15 years ago, we could have wished for an electric car, but or whatever, but 20 years ago, but it just wasn't there yet, or they weren't quite as, I'll say, aggressive as they are now. I mean, these electric cars now are incredible. So can you share any other success stories or that, you know, regarding this whole turn for the green? Is there anything else that you want to share as far as success stories, case studies, anything?
Sure. Yeah, there's a, as you know, anything that turns usually requires a motor to do it. Oh, yeah. And so one of the things we look at is coming up with new motor designs, smaller, more efficient, different types of processes. I mean, the type of motor that's in a car today, you would have never envisioned that as an actual production model. Those were things on the R&D shelf that maybe would happen. So if you look at, we actually build those not in the US, but in Taiwan, we do a lot of bus motors and other type of applications. But we look at HVAC is very large, right? Every HVAC operation in a building, in your home, has a motor with it. And so there's a lot of innovation going on with the low voltage drives and the efficiency of those motors. There's permanent magnet machines, and there's just a host of changes going on in the motor industry. And we think ourselves as TECO as being on the forefront of all that.
Oh yeah, it's amazing. Well, again, is there anything else that you want to share? I mean, I'm trying to figure out if I'm missing a good question. I know I've got a ton of them, I mean, but I think I've gotten most of them. I mean, in your conversation, you've touched on a number of them. I personally want to embrace this change. I think that ultimately, you know, it's going to make a better world for all of us. You know, and you did suggest that 35% adoption rate for the electric cars. That's a US number, right? That's our self-imposed.
Yeah.
What do you think about the rest of the, you know, the European community and other places across the world? Do you think that they're going to try to push for those too?
I think the European community is a little bit ahead of us. But I think the innovation change is going to be these, they call it 360 DC fast chargers. And yeah, as I say, you'll be able to charge your car in upwards of 15 minutes, enough to be like a gas machine, you know, that you can travel a fairly long way. And these are being put everywhere. And I think the utilities are looking at the grid and the stability of the grid and how to do it. And I think there's going to be a lot of battery BESS systems involved with packaging, so that you're actually drawing off the battery BESS system in the car charging port, and then the utility is feeding the BESS. We used to call it a trickle charge. Remember, our old batteries, you hook it up at night and you put the 2 alligator clips on it, it would trickle charge all night, and then you'd have a good battery. Right? And these new batteries are just so interesting. They have a complete battery control system, right? It determines, I know, how fast it can charge, depending on its heat, the ambient, the age, what type of program, software version it has. So these are very, you know, look at your cell phone. I mean, who would have think of a cell phone battery, right? I mean, they've got pacemakers they put in people that last 10 years. How does a battery last 10 years?
Yeah, it's amazing.
Battery's going to be the key, but everything that turns requires a motor. So if you look at that type of synergy, it's got to go together.
Well, let me ask you this, kind of switching gears a little bit. This past winter, Texas had a pretty rough experience with some power grid issues, right? Do you foresee these new batteries and new technologies helping with those kind of things as well?
I do. I think you're going to see. I mean, one of the things we've always, at least in the types of seminars I attend and things, they've always looked at the concept of your car with an electric battery in it. I mean, as an electric vehicle, is basically a electricity storage device that, with a two-way meter, they could use that. The utility could use that power back and forth. In fact, I believe I saw in the news this morning the F-150 you'll be able to actually connect up and power back into the grid through the F-150 car. I have to check on that, see if that was on the news this morning, which was kind of interesting.
Really?
But I think that's going with the concept that, you know, all these cars that will be sitting in the garages at night being charged, current charging takes way too long. Some of my kids have these electric cars, and even if they charge them all night, it doesn't quite take it all the way up. So the next day they drain it a little bit farther, and they charge all day and don't quite get there. Right? So these new fast chargers are going to change the industry. I mean, 15 minutes, you're charged. And now when you park your car at home and you plug it in, if the utility could draw off of that, that would help stabilize the whole grid. I'm not necessarily all involved with that, but I read a lot of papers on it, and it just sounds like a very exciting time to be involved in that type of business. It
really is, Dean. I mean, I'm super thankful that you took the time to share a little bit about this. I know that you know, there's a ton more information that you're probably not allowed to share yet or don't want to, but when that happens, will will you come back on to Lunch and Learn with Vince and share a little bit more? Because I have a feeling we've got some pretty cool things to be talking about in the near future. So good. So when do you think next level information is going to be out there, next level products? Looks like we're getting close, but I mean, 6 months, a year, 2 months. I mean,
I think the units the 360 fast chargers are being deployed now for some people. None of them are built here, but we will actually be building a unit here, and we'll be having the first units out within a couple of months. So I think maybe in a couple of months when I get the production line going, you can actually take a video shoot of the production line.
Oh, I'd love
talk
that.
a little bit more about it. And I think a lot more cars are coming out almost every month. Somebody's announcing a new car that's going to be able to use this type of vehicle.
Oh, wonderful. You know, we do offer a videotape plant tour, and you know, down the road, if that's something that interests you guys, we certainly can go down there and actually do some Q&A and share it on our social media. So it's something to think about anyway.
It is.
But so I want to just thank you for taking the time to visit with us. I can't believe it. We've already blasted through at least 30 minutes. And again, if you have anything else to add, here's the time to do it. If not, I have a couple of closing things to say, and then we'll move on. But it's been a real delight, Dean. Thank you.
Thank you too, man. You too. Enjoy it.
Well, folks, you just heard from Dean Sarandria with TECO-Westinghouse. He is one of my new heroes, and I hope that each and every one of you that is watching this will share it with somebody else. My goal, and always has been, is to take information and pass it on through YouTube videos to share with other people. Maybe 6 months or a year from now, or 5 or 10 years from now, somebody will be wondering how to do something, and they'll look back on this video and go, oh, that was the birthplace of how this occurred. So remember to like and thumbs up and subscribe and all the other good things that you can do on the website. But please give me a shout. You know how to get a hold of me over at empoweringpumps.com. And Dean, again, I can't thank you. I wish you all the best, and everybody over there at TECO.
All right. Thank you, Ben.